Now, in case of the tune collector oscillator, we use a tune circuit L1C1. Like the tune circuit is this one, L1C1. This is a tune circuit. We use tune circuit L1C1 in the where at the collector of common emitter. This common emitter configuration, and tune circuit is connected to the collector side, to the collector line. This tune circuit, okay, and then there is a feedback also with the help of the L2, and that is applied to the base, and it also supplies some energy to the tune circuit to make the oscillation sustain. And there's a formula. By changing L and C, we can have any frequency. We can get any frequency. Now, this is a very simple circuit. This tune circuit and L2, it is coupled. It is coupled with the tune circuit and connected to the base, and then VCC supply, and the biasing is with R1, R2, RE. This is bypass capacitor. This is again a capacitor to get through the AC and to block the DC. Okay, this is very simple circuit. R1, R2, RE for biasing resistors, and CE bypass capacitor. This is off-on switch, tune circuit, and L2 is coupled with the tune circuit. And actually it's a transformer, and primary and secondary coil of the transformer, and how much energy is coupled, it depends upon the number of turns of the primary as well as the secondary. Okay, the same is written here. So what happens when the switch is S is closed? When the switch is closed, what happens? The current starts flowing and oscillation build up at here. Okay, and there is a phase shift of 180 degree. Then this L2 is coupled with the tune circuit. L2 also gives a phase shift of 180 degree, and total phase shift becomes 360. So this feedback from here, the feedback signal comes in phase with the input signal. Again, when the switch on the circuit, current starts flowing. Here the oscillation build up, and common emitter gives a phase reversal of 180. Then again 180 phase shift comes here with the coupling, and total phase shift becomes 360. Okay, and that means feedback signal comes in phase with the input signal. That is the Park-Cosine criteria, and we said that the A beta in magnitude should be equals to 1 by adjusting all the biasing networks and the coil resistance of the coils, etc. Okay, now we're coming to the mathematics. These are the H parameter equations. First equation, second equation. The input voltage having two parts. This is voltage and this is also the voltage. This is input impedance. This is a reverse voltage ratio. This is the second part. This is the collector current. Collector current also having the two parts. This one and this one. Collector current is divided like that, this part and this part. Okay, this is current equation, this is voltage equation. This one is voltage, this one is voltage. This is current, this one is current, this one is current. HF equal forward current ratio. This is reverse voltage ratio. This forward current ratio. This is reverse voltage ratio. HI input impedance, output admittance. This is HOE output admittance. The E is used for common emitter configuration. So, like at here, VBE is the input voltage HIE. So this is this is not actually I1. This is, you make a correction, it is IB. So HIE into IB, this is IB, plus HRO into V0. HRE, there is a VCE, and VCE here denoted by, VCE is denoted by V0. Common emitter means this is our thing. Now IC is denoted by I2. I2 having the two parts, HFEIB, this is HFEIB, and then HOE not VCE, we are having V2. So 1 over HO is admittance, 1 over admittance is resistance. So this is resistance, and then VCE, we are having the V2. Then there's a, tune circuit. Tune circuit is what that, this is L1 and L1C and L1. This is a tune circuit at the collector side. This one is the tune circuit. Then it is magnetically coupled L2 coil, which is which then connected to the base, like that at here. This is a coupling because of the energy transfers here. Tune circuit, tune circuit and this coil there, they are coupled, and the coupling is capital M. So here the current is I2. Current I2 is flowing through this circuit. When I2 comes here, it is divided into two parts. I1 is flowing this side, and what the current left, I2 minus I1, it is flowing through the capacitor. It is flowing through the capacitor. So I2 minus I1. And I1 is coming from here. When I1 meets with I2 minus I1, it again becomes I2. Alright. Now, what is the impedance of this circuit? The reactance of the capacitor, it is 1 over JC omega. This part. 1 over J is the J operator because they produces a phase shift of 90 degree. So 1 over JC omega, this is the reactance. The reactance of the coil is GL omega, this is R. If this line and this line, they are in parallel, and parallel combination formula is R1 into R2 upon R1 plus R2. So R1 is what you say, this one is R1 or this one is R1 total. So this into this upon this plus this, like that. R plus J L1 omega, R plus J L1 omega, then multiplied by 1 over JC omega, and then the sum of the two. This is the impedance of this circuit. Hello. We are having a condition that R is small. If the R is small, R is less than omega L1, and at resonance, this condition, this is the resonance condition, omega square should be equals to 1 over L1C. This is the resonance condition, and we apply this condition in the formula of this impedance. Then impedance Z becomes equals to L1 upon CR. Now voltage at here, this voltage is V2, which is across the capacitor. It is equals to I2 into the impedance of this circuit, which is Z. Minus is because of the sign convention. So V2 equals to minus I2 into Z. Substituting the value of Z in here, which we already calculated at resonance, L1 upon CR. So V2 becomes equals to minus I2 into L1 upon CR. Now I2 equals to, this is a H parameter equation. Second equation, this IC mean, in our case it is I2, This is the current equation, and we are applying it here. Okay, HOE into V2 plus HFE into IB. This is H parameter equation. Substituting the value of V2 here. This is a V2 here. So this part is taken to the left hand side. I2 is taken as common. So this is the equation of 7. This is the equation number 7. Now looking here, this is the capacitor. These are, and this line L1 and R. These two are in parallel. The current through capacitor is I2 minus I1. Okay, and voltage across the capacitor is I2 minus I1 multiplied by reactance of the capacitor. I2 minus I1, reactance of the capacitor is 1 over jc omega. That is voltage between this point and this point. Along the parallel path, voltage is the same. So this voltage along this path, along this path, current is I1 multiplied by total reactance of this path, R plus J L1 omega. R plus J L1 omega. Both voltages are the same because these two lines are parallel. So equating the two and finding the value of I1. So this is the value of I1, and just simplifying it, and we get this value. Okay. After simplification, this is the value of I1. Now we multiply and divide numerator and denominator by j omega. Now in the denominator, j in multiplied by j, that becomes minus 1, j square, because j is an operator. So here it is not omega, j omega. So j into j is j square, which is minus 1. Okay. Equals to, now this is minus j omega I2 upon CR into L1C. This is equation number 8. M is coefficient of mutual induction between L1 and L2. Effective impedance of the Sirhindi circuit is, this is the Sirhindi circuit. This is a coil having the reactance and also some resistance. Reactance is L2 and the resistance is RB. Resistance of the base, actually R is the resistance of the base circuit. Resistance RB is the resistance of the base circuit. Inductive reactance is J omega L2, and to the input side, the reactance, the resistance is HIE. The total is inductance plus resistance of the coil plus the input impedance, which is HIE. If RB is greater than omega L2, then omega L2 is neglected. So IB is the current flowing along this path. So IB is the current flowing. There are two voltages. Some voltage appears because of the mutual induction, because of the mutual inductance. Some voltage appears here because of the mutual induction M. This voltage is J omega Mi1. This is the induced voltage. Because of this is induced by current I1. And another voltage is second voltage is HRE into V2. The two voltages are opposite. They oppose each other. Mutual conductance, and the second voltage HRE V0. Okay. So net voltage, the IB is net voltage divided by the resistance of the circuit, which is RB plus HIE. So substituting the value of V2 and I1, we get Hello my dear friends, please subscribe my channel and do not forget to click on a bell icon to get the notifications about my new work. Thank you very much.